All right, welcome to the video on rectangles. We talked about quadrilaterals, and in the same notes, we then moved on to parallelograms. I want to go ahead and bring in our flow chart. When we first started this, the main thing about this chapter is quadrilaterals. So every polygon we're going to talk about is a quadrilateral. The only two properties of a quadrilateral is they have four sides and the interior angles add up to 360 degrees. Once we moved on, we went more specific. We added properties that then made it more specifically a parallelogram. Because if it has these two properties but does not have all of these, then it's not a parallelogram. It's just considered a quadrilateral or a kite or a trapezoid, which we don't talk about. But once we move down this flow chart, look at the arrow, we're going to have these two properties, then we're going to add all of these properties, and it becomes also a parallelogram. So a parallelogram is a quadrilateral, okay? Now we're going to move on to rectangles. We're going to split right here. Today we're not going over on this side, we're going over here, okay? And if you are a Katy High School student, this is one of the last two pages, I think the second to last page in your notes packet. We're going to take the two properties of the quadrilateral, we added the 5 properties of the parallelogram, we're going to add more, okay? We're going to add 2 more properties to make it more specifically not just a quadrilateral and a parallelogram, but once you add these 2 properties, additional 2 properties, it's now going to be a rectangle. So these 2 additional properties that we're going to talk about are going to be, well, first of all, it says here, hey, all properties of parallelogram, which are also the properties of a quadrilateral. We're then going to add to it 4 right angles. So before we didn't have 4 right angles, now we do. So here, property, the number 2 listed over here, we're going to go ahead and draw in our right angle boxes. The next thing, we already talked about how the diagonals are bisected. They bisect each other. Well, once you get to more specifically a rectangle, not only are they bisected, but they are also going to be congruent. So right here, number 3 over here, we're going to go ahead and draw in, best we can, these. And I'm just going to put a tick mark here and here. Well, you know, I mean, number 2 right here tells you also that they're going to be bisected and congruent, so we'll go ahead and add these 2. I didn't in my original notes, but we'll go ahead and add that in. What this means is all 4 little tiny parts are congruent, meaning when you take each diagonal will also be congruent. So with these properties in mind, the 2 properties of quadrilaterals, okay, bring my flow chart back up, 2 properties of quadrilaterals plus the 5 of parallelograms plus the 2 additional ones, we now have 9 properties. We're going to go ahead and solve. Here we're going to just solving for x. We have, this is a rectangle, so our opposite sides are going to be congruent. So again, like I always ask my students to do and what I do in my videos and my notes, we're going to go ahead and write down the property. We're going to do opposite sides are congruent. This is a property of all parallelograms. And so we're just going to take the 2x minus 4 and set it equal to 36. This is a very simple 2-step problem. I'll go ahead and write it down. Add the 4 to both sides. We have 2x equals 40. And then x is going to wind up being 20. Next, we're seeing here these 4 marks that we put up here. So we are talking about exactly a rectangle. All right? And so we know that AC is going to be 6x plus 3. So right here, you can go ahead and write in x plus 3. And then DB, the other diagonal, is going to be 33. Well, the property of rectangles tells us that diagonals are congruent. So right in here, and I always put diags instead of diagonals. Please write it out if you need to. Diagonals are congruent. So again, we set them equal to each other. 6x plus 3 equals 33. We have 2 steps. Subtract the 3, and then divide by 6. Solving's going to go quick, okay? Now let's take a look here at what we have. We have that the measure of angle AEB, so from A to E to B right here, is going to be 12x. And the measure of angle DEC, D to E to C, is 10x plus 20. This is not going to be any of the new properties we learned about rectangles, parallelograms, or quadrilaterals. we need to go back to chapter 1, the basics of geometry, something that goes all the way through the entire year. Right here, we have vertical angles. And with vertical angles, we should remember vertical angles are congruent. Now, this is asking us to find the measure of angle AEB. So again, read carefully, guys. Okay, we're not just solving for x. We're going to have to plug back in for the 12x. We'll go ahead and set these equal to each other. 12x is equal to 10x plus 20. Go ahead and solve, well, it's two simple steps. We're going to subtract the 10x to get 2x plus 20. Sorry, 2x equals 20. And then we divide. We're going to find out that x is equal to 10. Now we go back into our angle here. The measure of angle AEB was 12x. I'll just go ahead. We're going to remove x. Physically, I just did it, right? We're going to plug in, we found x to be the 10. And this in turn will give us that measurement is 120 degrees. If you plug 10 in to the 10x plus 20, you will get 120 as well. All right, so here we're looking at, we are going to just solve for y, so we don't need to substitute in. We're given that AE right here is 24, and EC right here is 5y minus 1. Well, what can we do with all these properties we've learned about? Okay, again, here comes the flow chart. These two plus these 5 plus these two new ones. The third one just says all the properties of parallelograms. Okay, what tells us, what can we use? We're dealing with the diagonal. So the two things we talked about with diagonals is that diagonals are going to bisect each other, and that with rectangles, diagonals are congruent. Well, we're dealing with two parts of a single diagonal, meaning the property we're looking at is that our diagonals are bisected. Right here and here, these are congruent. So we set them equal to each other. 24 equals 5y minus 1, or if you want to use the symmetric property, 5y minus 1 equals 24. They will both be, you should get the exact same answer on both of them. I'm going to add 1 to both sides, and then divide. And then y is going to come out to 5. There's a lot of properties, guys. Start getting flashcards. I cannot tell you how helpful this will be. All right, number 5, we got this big rectangle. We got a lot of space, okay? It's a very, very simple concept. Here we have that this is a rectangle, quadrilateral A, B, C, D. Okay, again, starting with one of the vertices, or one of the vertices and going clockwise or counterclockwise. It is a rectangle, meaning it has all these 9 properties we have talked about. If the measure of angle DAB, so go from D to A to B, this angle right here is 7x plus 6, solve for x. Okay, so what do? We're going to use one of our specific rectangle properties. We already used the one where we have congruent diagonals. Now we're going to use this other property that we have 4 right angles. So with a right angle, we know that it is 90 degrees. Right in here, 4 right angles. We take our 7x plus 6 and simply set it to 90. Take our 2 quick steps, subtract the 6, and then divide by 7. We're going to get 12. And there we go. So we got to use both the new properties. Now, testing for rectangles. We did this with parallelograms. Now we're going to do it with rectangles. First thing we're going to do is we're going to look at the slope formula. Okay, and we're going to figure out, okay, do we have the 4 right angles and the congruent diagonals? Well, the slope formula is going to be a little different than what we did with parallelograms. Parallelograms, we use the slope formula to identify if opposite sides were congruent with the same slope. Now what we're going to do is we're going to look at the diagonals, okay? So let's go ahead. I'm going to pause the video. You're going to pause the video, sorry. Plot points J, K, L, and M on the graph, label them, and go ahead and connect them together. Now with our slope formula, again, we're looking at the diagonals. So I'm going to go ahead and draw in my diagonals, little dashed lines. With a rectangle, this is one way, okay? We want to find out if these are going to be, give me 1 second. Okay, disregard that. I was thinking of the wrong quadrilateral. We're not dealing with the diagonals. What we're doing is we're going to do exactly what we did with the parallelograms. I apologize. I'm not remaking the whole video because that one whoops-a-daisy. All right, so we're going to go ahead and do the exact same thing. Let's find out if opposite sides are going to be parallel with the same slope, exactly like what we did with parallelograms, okay? So remembering that our slope formula is our y2 minus y1 over x2 minus x1. So let's go ahead and take a look at side JK over here, okay, segment JK. So to find the slope of segment JK, we're going to take y2 minus y1. So we're going to have negative 6 minus 2 over negative 8 minus, J and K, make sure I'm looking at the right one, okay, negative 8 minus negative 10. We plug this in, we're going to get negative 4. All right, let's move to LM or ML. Slope of LM, y2 minus y1, 5 minus negative 3, and x2 minus x1, 2 minus 5. We're going to find out this is actually negative 8 over 3. Uh-oh. Go back and check your work if you want to, okay? That's the first thing. We find out, ooh, they're not the same slope. Go back and check your work, but this will come out to negative 8 over 3. That means these are not parallel. Guys, you don't have to check the other two. If you double check this work to make sure that you are correct, then you don't need to check the other two because they're automatically, these two are not parallel. You do not have a rectangle, okay? If you check 2 and they are parallel, you have to check the other 2. That's the difference there. So these, the opposite sides, are not parallel, not the same slope, just to kind of remind ourselves. So not only is this not a rectangle, but it's not a parallelogram. But it's asking, is it a rectangle? So we'll say no, because it's not even a parallelogram. The opposite sides have to be parallel. All right, so let's take a look now at the next problem here. We do have our slope formula again. Looking at exactly what we did, we have a different rectangle. I already drew it for us. I'm going to go ahead and do rise over run on this one. Okay, guys, I'm a very honest, blunt teacher. My students know that. If there are several different ways of doing it. I'm going to show you if there's an easier way to help you out. I'm going to show you that as well. Okay. With this is different than my answer key for my notes, so bear with me as I do this. You know, just not really looking at the answer key. I'm going to wing this one. Let's take a look at the slope of PQ right here. The slope of PQ, if we do our rise over our run, since we have the graph, PQ, we're going to notice we're going downward, so we are going to have a negative, and we're going to go down 1, 2, 3, 4, negative 4 over, and we're going to run 1, 2, 3, 4, 5, 6. This will then in turn simplify to a negative 2/3. All right, let's take a look at segment RS. the rise over the run, we're going to find ourselves down 1, 2, 3, 4. So negative 4. Running 1, 2, 3, 4, 5, 6. And this will end up being negative 2/3 as well. So we do have parallel sides. Again, you have to check the other two, because I'm going to tell you right now, on this guy over here, actually I'm not 100% sure, they may and may not have been parallel, but you have to make sure that both pairs of opposite sides are parallel. So moving on to the slope of segment PS right here. We're going to have a rise of 1, 2, 3 and a run of 1, 2. Rise of 3, run of 2. The slope of RQ, the opposite side, we're going to have a rise of 1, 2, 3 and a run of 1, 2. So we do have parallel sides here. So we have opposite sides, OPP sides are parallel because they have the same slope. But that just proves it's a parallelogram, guys. Just a parallelogram. So if we just go based on that, we can't say it's a rectangle. So we need to look at one other thing. Okay? Consecutive sides, one after another, are going to have to be perpendicular, forming the 90-degree angle. So what that means is segment PS right here and segment SR are going to have opposite reciprocal slopes for that to be a 90-degree angle, meaning we have to take this slope of PS, the 3/2, we have to, and especially my third period loves this, flip the sign and change the sign and flip that fraction. Okay, we have a little game show going. We change the sign and flip that fraction. So from this 3/2 from PS to SR right here, we have to change the sign, make it negative, and we have to flip the 3 and the 2, and that's exactly what we have. So we have opposite reciprocal slopes with consecutive sides making that 90-degree angle. So we're going to write down here consecutive sides, are perpendicular. You have to know what that perpendicular symbol is. That's why I'm putting that there. If you need to remind yourself perpendicular, please write it. Okay? They're opposite reciprocals, OPP recip, opposite reciprocals, making this 90 degrees. Okay? We already talked about the 90 degrees, but now we're looking at, how can we see it on the graph? Opposite reciprocal, consecutive sides, one after another. So here we can say, yes, P, Q, R, S. Start at P, Q, R, S. I just habitually go in clockwise order. Okay, P, Q, R, S is a rectangle. Distance formula. All right. What we're going to do with the distance formula, now we're going to look at the diagonals. Okay, now we're looking at the diagonals, and we're going to see if these diagonals are congruent. That was the other property we talked about, the right angles, which we just covered right here, and we're looking at they're the exact same length. So what that means is P to R, right here, the length of PR has to be the same as the length from Q to S, your diagonals. All right, so when we take a look at this, we're going to, actually we'll go ahead and note up here, the distance formula is going to be used to show the diags are congruent. Okay, write out the words if you need to, so I'm going to lower that down. Distance formula is used to show that the diagonals are congruent. So let's take a look at P to R. When we use this distance formula, again, you cannot count on the graph. Okay, it looks like, okay, 1, 2, that does not work that way diagonally. Along your X and your Y axes, horizontally and vertically, you can, but you cannot when it's diagonally like this. So here we'll have to use our distance formula. Again, I'll go ahead and write in the distance formula up here next to it as well. I'm going to take x2 minus x1, which will be -1 minus a -5. Don't forget, or you can put -1 plus 5 squared plus, we're going to take y2 minus y1, -4 minus 3 squared. Whether we get to the radical, which will be the square root of 65, or whether we plug it in, find out that it is 8.1. Either way, if you want to leave it as a radical, it's perfectly fine. They should both have the same radical. Now let's look at QS, our other diagonal. All right, looking up here at the points Q and S, x2 minus x1, -7 minus 1 squared, plus y2 minus y1, 0 minus -1 squared. This comes out to the square root of 65, or 8.1 as well. So right here, we can say it's the same distance, meaning they are congruent. So here we can now say, yes, is it a rectangle? Yes. PQRS is a rectangle. Proving rectangles on a coordinate grid is not the most fun, but we do have to do this, okay? So just remember that we cannot just use proving opposite sides are parallel like we did up here. We had to then take an additional step. Saying they're parallel just means it's a parallelogram, okay? Again, back to the flow chart, okay? Here we have opposite sides are parallel. That's just a parallelogram. We have to then take it a step further and prove one of these two. Either diagonals are congruent or the angles are right angles. If you prove that the opposite sides are parallel, this is probably the easiest in my opinion. Find the slopes and then see that the slopes of the opposite sides are the same, and then consecutive one after are opposite reciprocals. But again, you choose whichever path that you would like to. Please make sure you ask any questions to your teacher, or if you want to, you can search for other videos.